Okay, guys, I wanted to spend a little time talking about what we covered last week, dealing with K numbers and C numbers and homogeneous wall constructions. So first of all, let me let you in on the secret. K over X equals C. So the only reason we're using the K number is so that we can get to the C number. So then why would we use this K over X, where K is the conductivity and X is the thickness? Let me show you. Here's the table that we used from the train book. In my book it's page 365, but in your revision it may be a little bit different. At any rate, it's table 3-3. It's that through all the train books. And this is the table of building materials that we're talking about. And you can see there's building boards, insulating materials, masonry materials, etc. And then inside of each of those there's a number of different materials. Here is the K numbers. These are the C numbers. K is conductivity, C is conductance. K does not have a thickness attached to it. C does. Let's look here at plywood, for instance. Here's plywood, and here's the K number. Here's plywood 3/4 of an inch thick, and that's the C number. So C numbers have a certain thickness attached to them. K numbers don't. So we would use K numbers when we would have, for instance, with the plywood, something other than 3/4 inch. What if you have 1/2 inch plywood? How do you know what the heat transfer coefficient is? You don't. So we have to use the K numbers, divide them by the thickness, and that will give us the C number. In this case, for instance, 0.08 divided by 3/4 of an inch, which is 0.75. If you do that math, you'll find out it comes out to 1.07. See, they did that math for you already. Alright, are you with me? So K over X, the K number, you have to look at over here in the table. X is the thickness of the material, and once you do that math, you wind up with C. If it's a material that you already know the thickness for, and it's listed here in the C tables, you're done. You just grab the C number. One other thing that we talked about was this equation. Q equals area times C, or if you don't have the C, K over X, that could go there just as well, times delta T. So A is the area of the wall. So the area could be 20 feet by 15 feet, for instance. So we could find the area of this wall. And then if we need the thickness, that would go in the equation. That would be part of this part of the equation. Then the delta T is, we're going to have a temperature here. I'll call it T1, and on the other side I'll call T2. So whichever is the highest is we'll put here. So this is T minus T, T1 minus T2, where this is 100 degrees, I'm just making up numbers right now, and this is 50 degrees, for instance. So how much heat transfer are we going to get through this 20 foot by 15 foot wall that is 100 degrees on one side, 50 degrees on the other, and it has a heat transfer coefficient of, I don't know, you fill in the blank. I've put a number of problems on Blackboard for you for week 3. I think there's 8 of them there, so please work through those. Those are all homogeneous walls that I need you to find on this table and determine what the C number is. On some of those you may have to run it through this equation, but it's a very simple equation. Q, which by the way is in units of BTUs per hour, equals the area, foot times foot, times whatever the heat transfer coefficient is, times the difference in temperature from one side of the wall to the other side of the wall. I want to also bring to your attention. Down here at the very bottom, it says